Hey, good afternoon, everyone, and welcome to HPE Discover. My name is Andrew DeRocher, and I have the pleasure of serving as a principal technologist for sustainable transformation here at HPE. I work with a team of global technologists, and we help our customers navigate some of the challenges that have been brought on by the rising cost of energy we're seeing globally, some of the energy availability concerns we're seeing in certain regions, and the way that those concerns impact our success in the AI era. Our team serves as advisors to our customer teams, helping them develop tangible strategies and tactics that drive greater levels of efficiency, helping them draw a faster path to ROI in their AI initiatives. Today, I just want to take you guys through three things. I want to give you an idea of some of the pressures that our customers are facing as they look to bring AI initiatives to fruition. I want to walk through the 6-step guide that we've developed to drive higher levels of AI efficiency that we believe drives further success in the AI era. And then I want to leave you with an example of how we're applying that to one of our own projects here at HPE. Sound good? Awesome. Quick note about forward-looking statements during this presentation, and a reminder, as always, your feedback is appreciated. Please remember to take the survey at the end of the presentation. Now, while the age of AI has brought on an immense amount of promises for our businesses, what we found is that actually bringing AI systems into production is not without its challenges. We've seen that there's been a drastic rate of failures across the industry as teams have looked to get AI projects off the ground. MIT estimates that only a small percent of AI pilots have actually progressed out of the pilot phase and made it to full production. Does anyone want to take a guess how many pilots have actually made it out of production? 10% is a good guess. Anyone else? It's 5%. Only 5% of projects have actually made it out of the starting block and gone on to serve business value for their organizations. And now, while some analysts may look at this and see wasted time, wasted spending, our team looks at this and sees wasted resources, energy consumed, and hardware deployed that has ultimately served zero business purpose. Now let's imagine for a moment that we are part of that 5%. I hope that some of your organizations are, right? We can take a step back and pat ourselves on the back for a moment and say, we did it. We brought an AI pilot to production. Well, now we're facing a new headwind. We're seeing that millennial and Gen Z employees are actively sabotaging their own organization's AI strategy. Does anyone want to take a guess? And the key word here is admitting to it. So how many are actively admitting to sabotaging their own organization's AI pilots? Any guesses? 15 is a good guess. It's a little bit higher. 41% of Gen Z and millennial hires are actively sabotaging their own company's AI strategy. Now let me temper that language a little bit. When I say sabotage, I'm not talking about droves of Gen Z hires running into your data center and unplugging racks. I'm not talking about virus uploads. These employees are actively choosing to not engage with your AI initiatives. They're saying, I have concerns about fear of replacement, accidental misuse, and what we're hearing more and more is the fear of impact based on the energy consumptive nature of these AI workloads and the impact that they're going to have on our planet and our community. And so across that, seeing that these failures are all a result of not having a comprehensive strategy in our organization's AI initiatives. Without that strategy, not only are they not able to execute, they're not able to turn around and give further levels of transparency into their new hires, leading to confusion, fear, and in some cases, rejection. Now, I can't promise that in the 15 minutes that I have left that we're going to solve all of those problems or quell all of those fears, but what I can promise is that we're going to look for ways to build a strong strategy with efficiency built into it to achieve success in the age of AI. I can promise that we're going to look for ways to pursue efficiency to achieve ROI in our AI initiatives and help get some of those pilots out of the pilot phase. And I can promise that we're going to look for ways to provide transparency into your efficiency efforts to quell at least one concern there, driving levels of exceptions and higher levels of adoption. So let's walk through those 6 steps that I mentioned at the very start to explore how we can build efficiency by design into our critical AI initiatives. First step is building out that initial strategy. Now, when we collaborate with our customer teams, we bring HPE's unique POV on efficiency to the table. And that POV boils down into what we refer to as the 5 levers of efficiency. That's equipment efficiency, energy efficiency, resource efficiency, software efficiency, and data efficiency. Now, these levers were designed initially for general IT workloads, but what we found over time is that they apply really nicely to the AI lifecycle that our customers are familiar with. When we start out aggregating our data, we encourage our customers to bring an efficiency-led conversation to the table to understand what data is needed and the energy consumption related to how it's stored. We also then turn to the development phase and consider how you're building your software-led ecosystem around your AI initiative, making those tools energy conscious and resource aware. And then when we turn to tuning, training, deploying, and last but certainly not least, inference, we have to understand the efficiency of our equipment, our energy, and the resources we use to deploy those systems to meet the needs of our teams and our end users. Now, I don't have time to dive into this in depth today, but we spend a lot of time working on this life cycle in particular with our customers. But I do want to highlight 2 critical points on this life cycle. The first is that arrow coming out of monitor going back up into data. This is a life cycle after all. It's cyclical. We believe that our customers need to constantly evaluate and reevaluate their efficiency strategy to drive higher levels of efficiency and look for ways to minimize their impact across the life cycle. The other element that I want to highlight is this defined step here. The teams that we work with often skip this very critical step, but we encourage them to take the time here to define the business value of their AI use case, understand how they're going to demonstrate that value, and understand who is going to benefit from that value at the end of the day. And that's a perfect transition into step 2. Who's going to benefit from that value? We believe that AI cannot be brought to fruition by one team working in isolation. The inherent complexity of these workloads oftentimes requires a cross-functional or cross-organizational level of collaboration that our teams may not be used to. Obviously, this is a simplified version of what a cross-organizational team may look like, but you'll see that each of these teams have a specific emphasis on one of those levers of efficiency that I mentioned earlier. Your facilities team is going to help you reassess your relationship with cooling your infrastructure and understand how you can most efficiently deploy a cooling strategy across your AI workloads. Your energy procurement team is going to help you reevaluate your access to energy to meet the spikes in demand brought on by inference. But one team that I really want to highlight here is your end users. It's critical to collaborate with your end users early and often as you develop your AI projects. Not only is that going to ensure that they see the value in those initiatives, driving further levels of adoption when they go to deployment, but it's also going to help you uncover new pockets of data that you may not have been aware of at the start. What we found is that oftentimes our users are holding on to little pockets, little kingdoms of data that may provide additional value to your AI projects. So we've planned our strategy, we've assembled our team, and then in step 3, we can start to assess what type of model we may need to meet the needs of our use case. Now, it's easy to grab the latest and greatest model off the shelf. I know that when I work on projects here internally at HPE, I'm oftentimes inclined to do so. But what we found is that the latest and greatest model does not always equal the most efficient model. Hugging Face maintains a leaderboard of the most energy efficient models on its site, and it consistently ranks small, distilled language models highest for their efficiency. Now, as small language models continue to mature, we're seeing that there isn't necessarily a significant impact to performance or accuracy of these models that we might expect. Now, SLMs may not be the right tool for every single use case, but we encourage our teams to understand and consider the efficiency of these models as a tool in their toolbox as they build their strategy. Next, I want to zoom out even further and assess the infrastructure that our AI system will be hosted on. We're anticipating that the energy consumption related to inference will rapidly outpace that of training out till 2030. And that's why we recommend that our teams select their model first, because anticipating the energy consumption associated with the inference of that model may force us to make a drastically different infrastructure decision when we go to deployment. If your team is using a small language model, you may be able to deploy that on a smaller edge device out at the edge serving your end users. If you're looking at a 70 billion parameter model serving thousands of users, you may need the full power of a data center behind it. We also like to use this as an opportunity to remind our teams that just because we're focused on AI immediately, and that seems to be the main driver of our team's levels of execution recently, we can't forget about everything else. Now, this chart is not to scale. If it were, I'd need about 4 more screens going off and to the right here. But we expect that the standard compute energy consumption is going to continue to dominate the data center space out until 2030. So we encourage our teams to look beyond AI and develop an efficiency strategy that spans their entire IT ecosystem. So we've developed our use case. We've assembled our team. We've selected our model. We've determined the appropriate infrastructure footprint. Now again, we're going to keep zooming out even further and understand the efficiency across the data center that surrounds it. Now, we're only going to talk about cooling today, and very specifically, we're only going to talk about the facilities side of the cooling equation. But just know that we have experts across the floor focused on direct liquid cooling and some of HPE's other cooling expertise that we can tap into. But what we find is that facilities level cooling is something that our IT operators often don't consider. Now, cooling efficiency is a multi-variable problem. But what we're seeing is that operators are starting to realize that options that may be energy efficient may end up being highly consumptive in another critical resource, and that's water. Historically, our operators have deployed evaporative cooling in their facilities for a number of reasons. It was thought of as energy efficient, it was thought of as a cost viable option, and hey, it's worked for us well in the past. If it ain't broke, don't fix it, right? But recent research is showing that dry air cooling is actually, in certain climates specifically, is showing levels of energy and cost parity with evaporative cooling, allowing operators to reduce their reliance on local water resources, reduce their utility costs, while not seeing a dramatic spike in their energy bills. There are other developments in this space that are giving our operators more and more options to consider as they deploy the most energy and water efficient options for their facilities. Now, just because air-cooled chiller with economizer is the most up and to the right here, seeing it's the most energy and water efficient, does not automatically mean that it's the best option for every single data center across the world. There are a number of asterisks next to this. Certain solutions may only be available to be deployed alongside certain IT cooling systems. Right? If you've moved to direct liquid cooling, some of these options will be available to you. If you're running air-cooled workloads, you may be limited to a certain number of options. There are certain climates where some of these solutions may not be effective, leading some of our customers to actually reconsider where they're deploying their workloads to take advantage of colder climates and the cooler conditions there for free cooling days. And the glaringly absent axis here is cost. Some solutions are more expensive than others. There's no one-size-fits-all answer here. It's all about driving the most efficient system across the board, considering local resource availability and supply availability, the average climate in the region, and some of the cost pressures that our organizations are under. Now, last but certainly not least, I think you guys can see where this is going. I'm going to zoom out even further here and consider our impact beyond the walls of the data center. Now, raise your hand if you've seen a headline about AI energy consumption in the last week or so. Yeah, almost everyone, right? We're seeing headlines every single day about the energy consumption and more about the water and other resource consumptive nature of our AI workloads. In some cases, we're even seeing community pushback in certain regions of the world. And a lot of that pushback is coming from some of the conversations around cooling that we saw on the previous slide. We believe that by pursuing efficiency across our AI deployments, we can drive further acceptance of the resource consumptive nature by limiting our impact and then turning around and being transparent with our community leaders to collaborate with them, to relieve concerns while successfully executing on our goals. So it's all about transparency into your efficiency, working together alongside communities to create transparency into that reduced level of impact. I want to wrap up today with something that I am personally passionate about, and it's how we're taking some of these concepts and applying it to some of the internal projects that we have going on here at HPE, drinking our own champagne, so to speak, or in our case, eating our own honey. Now, I have the pleasure of working out of our global headquarters just outside of Houston, Texas. Come on down and see us, y'all. We love having visitors by. If you do come to our campus, you'll notice that we're taking care of a colony of honeybees. Now, not only is this a way that we can benefit our local ecology by providing support and homes for our local pollinators, it gives us the platform and the opportunity to work with local and national charities that align with our Force for Good pillar. Now, we're a tech company at the end of the day, so we couldn't help ourselves. We started teching these hives out, outfitting them with sensors and video and image analytics. And what that led us to believe after we've collected all of this data is that we can develop an agentic AI platform to monitor the health of these hives and look out for anomalies that may lead us to believe that any of these hives may be at risk of collapse. That's exactly what the team's done. It's developed this agentic system to constantly vie for the health of these colonies. And we started asking ourselves, if we're going to deploy AI for sustainability, how do we deploy that workload as sustainably as possible? So we employed those strategies that we just explored during this presentation to drastically decrease the energy consumption of this project. First and foremost, it seems really simple. We ensured that our BIOS settings were set to the most energy efficient settings we could, significantly decreasing idle energy consumption, in some cases as much as 50%. We find that this is actually the first thing our customers do. We ship our devices with energy efficiency features turned on. And the first thing our customers do is turn those features off and set them into performance mode. We get it. You bought a Ferrari, you want to drive it like a Ferrari. We understand that, right? But learn from our own experiences here. We found that this did not make a significant impact on our performance while making a huge difference in our energy bill. We also changed between different model sizes, testing for accuracy, response time, and most importantly, and for our concerns here, energy consumption. We found that a model with fewer parameters actually cut down on energy consumption while still allowing us to gain effective insights into the health of our bees. Now, this is an active project at HPE that we're still all buzzing about, so if you want to learn more, the Customer Innovation Center booth is right around the corner, and they'd be happy to explore this project with y'all. So I'll wrap with this today. We believe that efficiency is success in the age of AI. I hope today I've given you some things to think about, some things to consider, and some questions to go back and ask your team when you get back home from Las Vegas. I encourage you to leverage our team's expertise, whether it be through our online papers that are readily available on hpe.com or engaging with our team directly. Hope you enjoy the rest of your time here at HPE Discover. I appreciate your time, especially during your lunch break, exploring this critical conversation with me here. And I thank you for all of your attention today.